Hi, I'm Dale Schroyer. I'm a senior consultant with ProModel Corporation, and this is the Robert Wood Johnson University Hospital Flexible Operating Room Suite model. This model was built for two reasons. Robert Wood Johnson was introducing case carts into their system and wanted to make sure that they were properly resourced so that there was not going to be any patient delays added to the system because of the introduction of the case carts. The secondary purpose was to investigate the operation of the system itself and to be able to understand what are the constraints on throughput and end-to-end cycle time for the patients flowing through the operating room suite there at Robert Wood Johnson. Give you just a little tour of the operating room suite area here so that you understand what the patient flows look like and where they're occurring. This is the main OR area. There's 20 main ORs dedicated to inpatient surgery. This is the main PACU where those inpatients recover. The area to the left is the cardiac PACU dedicated to recovery of cardiac patients. Inpatients actually come down from the inpatient units on these elevators here in the center, and if the OR that's supposed to receive them for the procedure is not quite ready, this small set of bay areas here is used as a kind of a staging area prior to those patients flowing into the OR. This is the same day surgery area where all outpatient surgery occurs. The patients enter from an entrance here on the side of the building, come into the lobby area here and check in. If the area is not ready to bring them in and pre-op them, they wait here in this waiting room. Once the area is ready to receive them, they come in and pre-op in this set of bays here. Once their pre-op is complete and the operating room is ready to receive them, they flow into one of these 5 ORs here to receive their procedure. Once the procedure is complete, they come out of the ORs and recover in the same day surgery PACU center up in this set of bays here. This is the pediatric area. Pediatric patients come in and pre-op in this set of bays here, flow into the main ORs to receive their surgery, and then come back and recover in this PACU area in here. This model includes several visual cues to tell people what's going on as the model runs. Over here we have a patient color legend, so the patients change color depending on what stage of the process that they're in. If they've just entered the process and have started flowing through the OR suite, they're their normal icon color. If once their pre-op is complete and so they're ready to go into an OR and receive their procedure, they turn yellow. Once they've completed the procedure in the OR and have exited to a PACU bed, if they're in first stage recovery, they turn green. Once they have finished first stage recovery, they turn red throughout second stage recovery and until their exit from the system. We also have some counters that show how many people are waiting in the same day surgery queue here, waiting to flow into same day surgery. One of the advantages of this model is that we have these expansion areas that are available to add capacity to pre-op or PACU in any of our patient flows coming through the operating room suite so that we can determine quickly whether each of those areas is a potential constraint on the patient flow through the OR, and if we wanted to add capacity, how much capacity we would need to add to improve the patient flow through the system. So this is the model as it's operating. You can see the inpatient flowing into the bays here and being ready for their procedure. We see our same day surgery people coming in. You notice that once their pre-op is complete, they turn yellow. One of the other things to notice is after they leave these yellow markers. Those are to show that those beds are dirty and they require the nurses to come over and clean those beds before they're ready to be used for pre-oping another patient. You can see our patients are flowing into our ORs here, receiving the procedures, and then they come back out to their respective PACUs. And you can see down here in our main PACU we have inpatients that are in first and second stage pre-op. Over here are same-day surgery. We have the same thing with outpatients in first and second stage pre-op. Our pediatric patients, this is showing the new configuration of the floor plan. Are pre-op here, and then they flow up to the 7th floor area here to receive their procedure in one of these ORs, and then recover in their dedicated pediatric PACU. This former PEDS PACU down here is being used as a PACU dedicated for patients that are going to the ICU, so these are extremely long, complicated recovery type of patients that are all moved down here. These changes were made as this model went and developed, because it was built to be an extremely flexible model so they could use it for the long term. And when we found that the case carts basically would work, we needed a few extra case carts, and the single case cart washer is a very critical point of failure in the system, so that allowed them to be able to be prepared for that eventuality. We found that the PACU spaces were the limiting factors and constraints on the flow of the patients through the OR suite here. And so that's why these changes were made, were basically to be able to give us more capacity in the PACU, separate out specific flows so that we had a smoother, more homogeneous flow through the OR area. So this is the input spreadsheet for the model that we just saw operating. This spreadsheet serves several purposes. First of all, it acts as a repository for all the data that is then fed into the model and used inside the model. This also makes it easy for hospital personnel to update the information or run scenarios by changing the information themselves. Thirdly, it can operate the model, this spreadsheet, externally so that they don't ever have to touch the model software if they don't want to. So this first tab handles all of the scenario parameters. So you can see the scenario parameters are switches that we can change that change the operation of the model. And we can change literally everything. So we have very overarching profiles, and we'll walk through each one of those tabs very quickly in a minute, or specific switches that change types of behavior. So, for example, this one, which is the patient arrival time, tells us how far ahead of their scheduled procedure the patients are supposed to arrive into the operating room suite. And you'll notice that each one of these switches then has a tooltip that tells the people using the spreadsheet to run the model what the legal values are and what the format of the inputs are. So we have everything from PACU close times to extra capacities, and how many patients per day, maximum flow through, how many cart washers we have, whether the scenario will run or not, and we even control the start and end dates and times for the models right here in this spreadsheet. If I were to push this Run Scenarios button, this information would be loaded into the model. The model would then start up and run through the time period designated here and then complete. So here are the different tabs that we use. This is the process tab, so it traces each patient type through all the steps that they go through in the OR suite, which personnel perform those actions, what backup people that we have for those primary people that are doing those actions, the times that it takes, all of that sort of thing is designated here. This is the cases information, so we can repeat exact known history if we want by using this case information that tells us the surgery date, the service, all the key characteristics of the surgeries that have occurred over a given time period, and we can recreate any set of this. So we can use all of it or only portions of it. It depends on how we set the model to run. We have a block schedule that tells us which surgical blocks are assigned to which OR rooms on which days of the week and which weeks of the month. We have staffing that tracks each individual staff member, their start and end times and the days that they work, as well as what overarching work group they're a member of. So we show all of the different types of people that are used in our OR process here. Our SPD tab simply tells us how many carts worth of equipment are used by each of the individual procedures. Our location assignments tab tracks all of the locations in our model and says what are they used for primarily, and if they have a secondary use, what is their secondary use. And in that way we can use the spaces somewhat flexibly depending on how we assign them here. We also have a procedures tab that lists all the procedures that occur and then their triangular distribution of time that it takes for the procedures, for the turnover after the procedures, and optionally the setup time for that procedure. We have a room restrictions tab that defines special use rooms such as robotic rooms, add-on rooms, trauma rooms, and also the legal rooms to use for specific types of services. And finally, our case card tabs simply controls the use of our case cards and allows us to assign them to specific surgeries, so we can say this service uses case cards or this service doesn't, and this was used to test the gradual introduction of case cards into the system by assigning them to a few and then a few more and that sort of thing to be able to understand where the maximum amount of case cards were required. This is the output that we get from the model, so it shows you the type of information that we have to make decisions on. So this is resources in use. We show a time-based graph of our resources, how many are in use by different type of resource, and then we also show an average over the entire model run. We do the same thing for our throughput, so that we show the time-paced change in the throughput of patients through the OR suite, and then the amount of patients averaged over the entire model run. We also break that down then by service. So each of our surgical services are listed here, and how many patients were seen by that particular surgical service in our ORs is shown here in these bars. We break down the time that each patient spends flowing through the OR into different stages. Pre-op, receiving their procedure in the OR, and then post-op, and we track the amount of time they spend in each different configuration, each different scenario of our model in each one of those stages to make it easy to compare then what that change to the model operation has actually changed in the amount of time the patients are spending flowing through the ORs. We have an OR utilization report that shows the amount of use of each one of our particular OR rooms. And then we show a profit report that shows how much profit is generated in each of the different patient flows, so main OR, peds, and same-day surgery, as well as overall. So this is a fully costed model. So to sum up, this model accomplished all the objectives that Robert Wood Johnson set out for it by being able to show that there were small tweaks required to the case card system to ensure the case card system would properly supply the operating room suite in its entirety. It showed that our PACUs were the limiting factors on flow to the ORs, and it's been used over the course of 2 years to investigate a series of different improvements to the OR suite area to improve both the patient experience and hospital operations.